Good day, scientists. What I'm going to talk about now is a topic. That's the topic force, right? So I'm going to just introduce you to forces. Now, when we are dealing with forces, we are just talking about either a push or a pull, a push or a pull. So say for example, I can just make use of this box that I have, or this container. So we are just saying, whenever we are talking about force, if you check on this box, it's just resting on the table, on the top of the table. So we can apply force, right? We can apply force, right? So it's either a push, right? Or we say force is a pull, right? So it's either a push or a pull. That's force. Now, whenever we are looking at force, there is a special tool that is designed to measure force, right? And this tool is known as a force meter. So this is an example of a force meter, but this force meter is specifically designed to be used in laboratories. It's used to measure small forces, right? Now, so whenever we are measuring it, it's supposed to be in this position so that we put our weight here, right? Then it will then what measure the weight of an object. But this one is an advantage because it can as well measure the mass of the object, right? So on this force meter, there are some markings that are shown on the force meter, right? Sorry, they may not be seen very clearly, right? But on this special tool, which we call the force meter, there are units, right? The units that we use to measure force. And the units are on this side where my fingers are, right? And the unit is newtons, right? That's the unit. And this one it's marked in terms of what? 10 strokes. So which means it's what? 0, then 10, 20, 30, 40, 50, which means it can measure up to 50 newtons. Then that's the force meter. Then we also have another one. So they are in different shapes and different forms, right? So it's another force meter as well, right? So that's the force meters. And the unit that is used to measure force is what? Newton. So normally we use capital letter N to represent newtons. If you use small letter n, then you are not going to be marked correct. It will be regarded as a wrong answer because the symbol is not correct. So it's capital letter N. Fine. So force is either a push or a pull. Now I'm just going to have some few demonstrations on the effects of what? The effects of force. The effects of force, right? But before I deal with those small or just few demonstrations on effects of force, let us just talk about the types of forces, right? What are the types of forces that you know, right? It's like if I will do the demonstration again to say force is either a push or pull, right? In this case, I think you can see that in order for me to push this box, right, I must be in contact with the box. Therefore, I'll then be able to push it, right? So I must be in contact with the box so that I will be able to push it, right? At the same time, I must also be in contact with the box so as to pull it, right? So it then means that the first type that I've just talked about is what? Contact forces. Contact forces. I must be in contact with the object so that I can push it or I can pull it. That's contact force. Then the other force that we must also know is known as field force. Field forces. Now, whenever we are talking about field forces, a very good example, it's this object here that I have, right? Normally, we call it is known as a bar magnet. So this one is a bar magnet, right? These colors are indicating or are showing you the poles of the magnet. We have the North Pole and the South Pole. But this one here is also a bar magnet, but the poles are not labeled, right? Now, these bar magnets can exert a force, right? They can either push objects or pull objects, right? So, these magnets, they possess a certain type of a force, right? The force that they can exert on objects is what we call the field force. Yes, it's magnetic force, but it falls under what we call field forces. So around the area or the space around this magnet is having what? It's what we call the field around the magnet. So whatever is in the field is near the magnet. If it is a magnetic material, it can either be attracted or it can be repelled. So this magnet has a field or an area onto which a magnetic material can experience the force. So this space where the magnetic force is felt, right, we refer to it as magnetic field. So the force that is within the magnetic field is what we are referring to as the magnetic what? That's the field forces, the field force, right? So whatever is in its field is going to be attracted or is going to be what? Pushed away. That's the field force. So I can make use of this object here, right? These two, there are the two magnets. I've got this bar, the bigger one, the longer one, and this other one, right? So as I move this closer and closer, I just want you to see what will happen, right? As I move closer and closer, what is it that is going to happen, right? You see, I think you have seen the movement there, right? It's because of the field force that it experienced from the other magnet. Again, you see, it turned, right? So it means that end is being pushed what? Away, right? So that's an example of a field force. The force that is exerted by another object and it's felt from a distance, right? Again, let's check what then happens this time. I've turned this bar magnet around. Let's see what happens. They are not yet in contact, isn't it? Right? They are not in contact. You see, it has moved again. So, which means it is in the field into which the magnetic force is felt. So, this type of force is known as field forces. The objects are not in contact, but they are exerting what? A force onto each other. The objects are not in contact, right? So that's the second type, which we call the field force, right? So then with another bar magnet, right? If we move them closer and closer to each other, what happens? Let's see what happens, right? They are not in contact, you see? The other one moved. Let me turn it around and see what happens, which means the other magnet has been pushed by the other magnet, right? Then I think you've seen what happened there, right? I turned it around. Let's see what happens this time. When I move it closer and closer, there's a gap. You see, it has been pushed away. That's a force. A force has been exerted. The force is magnetic, right? We'll talk more about magnetic force or field forces later on. Then let's just turn it around and see what happens when you bring it closer and closer. Right? Then you see what happened. So they attracted each other, right? So they are now in contact. But before they were in contact, they were not in contact, right? There is a gap or a distance in between them. So as soon as they are close enough, then they can attract each other and they get in contact, which means the magnet or the magnets experienced force, right? So the force whereby, the force that is felt by objects which are not in contact is known as field forces. So that's by the magnets. That's the same force that you talked about in grade 8, when you talked about planets. The planets are revolving around the sun. Why are they orbiting around the sun? It's because of the force of gravity from the sun. So they are moving right around the sun because of the force of gravity. So that force is known as what? As field force. We'll talk more about field forces later. Now, let us now look at the effects of forces. Effects of forces. One, I think you've seen what happens here. When I bring this closer and closer, once the force is felt, what is then going to happen? That's the effect of force. The effect of force. See what happens. You see. So there is movement there. So it moved because it is being attracted. When it moves, then they're in contact. So there is movement. Whenever force is applied, there is what? Movement, which is going to be caused. So another object is going to move, right? Then again, in this case, let's see what happens, right? Again, that's attraction. Let me turn it around and see what happens. Is there any movement that is going to take place when they experience or when they exert a force onto another object, right? That's what is happening, right? You see? That's, again, we are just showing that there is what? Movement is going to be what? Caused whenever there is force, or whenever force is exerted, right? Now, then, let's look at another one. Another effect of force. Right, let me just make use of these magnets here. All right. We just want to see what will happen when we move this magnet. As it is pushed by these other magnets, then what happens there, right? Is there anything that is going to take place when we move it, right? Right. We are moving in that direction, right? See what is happening now, right? It's turning around. We are moving it, going that way. Then it goes that other way, which means there's change in direction, right? Direction can be changed when an object is moving, right? That's what the effect of force is. There is a force from this magnet, there is a force from this magnet which is pushing it away, but as it moves closer and closer to this other magnet, then it changed the direction, right? So that's again another effect of force. Objects, when they're in motion, they can change direction. Right. Then I've got this toilet roll. Right. Now we can apply force, then it moves, right? Apply force, then it moves, right? So a little bit, then more, right? Small force, big force, right? I think you can as well see that the speed at which it is rolling can also change depending on the amount of force that is being applied. So speed can increase, right? That's again effect of force. Then I've got this role, right? This role that I have here, when force is applied, what happens to this tissue roll? Right? I'm going to apply force there. And let's see what will happen when we apply what? Force. This is a weight, right? It's 500 grams. Put it there. What happens? Right? Then we apply force there. What happens, or what happened to the shape? Right? What happened to the shape of this tube? Right? I think we've seen what happens. It was circular, but because of the force that we applied, the shape has been deformed. So the shape can change, right? The shape can change, right? That's the effect of the force. Then again, going back to the tissue paper, right? This is the height. This is the height of the toilet tissue paper. Then we can apply force there. What happens to the size? Right? What happens to the size? Remember, right? It was from the table to up to this height, but force has been applied. What happens to the size? You can see the size has been reduced, right? That's the effect of force, right? Then we can as well have, or we can as well make use of the rubber bands. This is the rubber band, right? Then I'm going to apply force onto one end of the rubber band. Then we're going to see what happens. There we go, right? I've just applied force onto one end, right? This is elastic. Then objects can be stretched, right? Which means they're going to increase in length. It's again one effect of the force, right? So those are some of the effects of force that you need to know with regards to forces. So whenever force is applied, there are some changes that are going to take place, or there are effects that are going to take place, right? Then remember the matchstick. If you want to light something, then you are just going to what? To scratch the matchstick head onto the match box, right? And then it produces what? That flame, it lights, right? So again, it can produce what? So it's just like if you rub your palms, right? You find out that after some few seconds of rubbing your palms against each other, you feel what? Your palms are warm. So heat is as well, again, a product of force. So that's just the introduction onto forces, my grade 9s. So I hope you are going to learn more about forces in our next presentation. Thank you. Have a good day.